In the following video, I have shown some examples of using the Ericsson flanker task and handheld buzz controllers to measure decision-making performance during a match simulation. So first off, I will show how to connect the buzz controllers to the computer. First off, you need to download two sets of software. The first one's called Simple HID Write, and the second is the Joy2Key. Now once these are installed, firstly double click on Simple HID Write and run this program. And you'll see a window like this come up. What you need to do is select WBuzz in the top half of the window, and in doing that you'll see selection of WBuzz. When this is selected, you need to type in 00 into each of the 7 boxes, as you can see at the bottom of the window. Now once this is done, if you select the right button in the bottom left hand corner, you'll see a row of zeros come up. Now when the controllers are turned on, every time you press one of the buttons, 2 rows of numbers will come up each time you press this button. That's all you need to do in that piece of software. The second, following this, click the Joy2Key software and run this program. Now what this program does is assign a button on the buzz controllers to a keyboard stroke. Now what we've done here is simply use the red button at the top of each controller, which is button 1 and button 6 on the 2 controllers. Now all you need to do in this program, in the top box for setting keyboard emulation, just hit whatever keyboard stroke you'd like to use for each of those buttons. So in this instance we've used S as a left hand response and K as a right hand response. Now once you've hit OK and set these two up, you need to keep these two windows open and select a notepad and just press the 2 buttons that you've assigned and to see if these are working correctly. And as you can see here, the S and K buttons are working as we can see in the notepad. We utilise the Ericsson flanker task as a method of assessing psychomotor performance. Now specifically what we were looking at was decision-making accuracy and response time during the team sport simulation. The structure of the Ericsson flanker task is based off the previous work of Davranch and colleagues, whereby we utilise three circles horizontally displayed on the screen in front of the participant, and there were 3 different levels of difficulty used to assess decision-making performance. The participant is required to respond to each stimuli, only indicating the colour of the middle circle, which is known as the target circle. And this will be one of 4 colours, either blue, green, red or yellow. A blue or green circle will indicate a left-hand response, whereas a red or yellow circle will indicate a right-hand response. This first example is a congruent stimuli, whereby the colour of the 2 flanker circles are the same colour as the target circle. So in this instance, the target circle is blue, the participant should respond with a left-hand response. This next example is known as a stimulus incongruent example, whereby the 2 flanker circles, which are green, correspond to the same response as the target circle, however is of a different colour. In this example, the target circle is blue, so the correct response again should be a left-hand response. The last example here is what's known as a response incongruent stimuli, whereby the 2 flanker circles are a different colour to the target circle, however the colour of those flanker circles correspond to the different response. So in this example here, where we have red, blue, red, red indicates a right-hand response, whereas the target circle again is a left-hand response. So the participant again is required to respond left, however the 2 flanker circles are there as a further distraction from the target circle. So it indicates a more difficult decision-making processing compared to the last 2 examples. Now we can see how the Ericsson flanker task works. There are 15 stimuli presented over a 1-minute period, so that's 1 stimulus every 4 seconds. Prior to the stimulus being presented, we have a cue, just to indicate that the stimulus is about to be displayed. Once that stimulus is displayed, the participant is required to respond as quickly and as accurately as they can to the stimulus. The congruent examples are displayed 50% of the time, with the stimulus incongruent and the response incongruent examples being displayed 25% of the time each. Now we can see how the team sport simulation comes together. The subject is holding the buzz controllers in their hand the entire simulation, and the Ericsson flanker task is completed at various stages throughout the simulation. On the top screen, we can see the physical demands displayed, whereby the subject is required to follow that red line as closely as they can, with the green line being their instantaneous speed. On the bottom screen, we can see the Ericsson flanker task being displayed, as I said, at various stages throughout the simulation. Overall, the simulation goes for 100 minutes, replicating a typical team sport match, and there are 6 different velocity bands that the subject is required to maintain with a speed change on average once every 10 seconds, and this is based upon the reliability paper from Sorotic and Coots on team sport replication on a non-motorised treadmill.